is the continuation of our C programming language tutorial. In today's class, we are going to discuss about dangling pointer. First of all, hi everyone and welcome to this channel Easy Engineering. Today we are going to discuss about dangling pointer. First we are going to see about that and the definition of it, and then let's see what does it mean, and along with some examples. Okay. Then first of all, it is a pointer that points to memory that has been freed or is no longer valid. See, it is a pointer. We know about pointers, right? See here, this is a variable in memory. Just right? Yes. This is a memory. In memory, this variable n will be stored, right? So this memory will be having some address, some starting address and some ending address. So this starting address is stored in pointer, right? Then that is known as pointer, right? That is a variable which stores the starting address of a variable. Okay. Then that pointer that points to memory that is been freed or is no longer valid. See, this is a function. If inside a function there is a variable created, in this there is no variable, right? Let me see. Yes, this is a function, right? Void func. Now in this function we are creating a variable x. For some instance, remove the static. Okay. Yes. Now we are creating this x variable. It is allocated with some memory when this line of code is executed, right? When this line of code is executed, then after the completion of this function, this will be erased. Like, yes, this will be erased. So there is no memory related to x, right? So then if that pointer which points to this variable is written outside the function, then that cannot be accessed, right? Because that variable is not at all existed. So that is known as dangling pointer, right? Means that is a pointer which points to the variable which is removed or freed, like which is not valid again. Okay. So using a dangling pointer leads to undefined behavior, including crashes, corrupted data or security issues. Due to this dangling pointer, we will be having some threat of our data, like security issues, like if we store something and where dangling pointer exists, then that will be corrupted, means that can be hacked. Okay. Then some common causes of dangling pointer. Causes. What is the meaning of causes? That means what are the reasons to get dangling pointer? Okay. What are the reasons of creation of dangling pointer? So there are mainly three causes. So let's discuss about all of those. First one is deallocating memory. See here, malloc, calloc, we have already discussed about these in what is that? That is dynamic memory allocation, right? We have discussed about malloc, calloc, free, all those in dynamic memory allocation. If you wanna refer, you can refer in our channel. Okay. So deallocating memory, that means we are allocating some memory and after that we are deallocating it, means that is no longer in usage. Okay. That variable is no longer used. That's why we are deallocating it, means we are freeing it. Like, see here, we are freeing it. Okay. So that is the meaning of deallocation. This is the syntax of deallocation. If you have referred dynamic memory allocation video in our channel, then you can get an idea of this. Okay, then this is the this is the syntax of a malloc, means allocating the memory. Okay, this is allocating the memory and then giving a value, assigning a value to this pointer, where value at pointer is 10, and free PTR, this is memory is deallocated, pointer is now a dangling point. Now after this line, if we want to access PTR, access this PTR, then that cannot be run, that program will not be run, that line will not be run, and hence it will be getting that error as dangling pointer. This is the reason of getting dangling pointer when deallocating memory. Okay, then returning address of a local variable. See now, local variable, what is the meaning of that? It is a variable which is created inside a function, right? Which is inside a function. Let me change the color. Yes, yeah, which is inside the function, the variable which is created inside the function. This is the function named getPTR, and inside that we have created a variable named x. So see, x is local and destroyed after function ends. See here, return %x means address of x, right? Where we are accessing the address of x after that function. Okay, before that, inside that function only, but if the program is run, then that line will not be executed. That's because see, this will not have this will have some memory inside this, but after this function is ended, this memory will be destroyed, as you all know. So that's the reason we cannot return the address of this local variable. Okay, we can return the address of global variable. That's because means throughout the program that variable will be present in the memory. Okay, but this is a local variable where that memory will not be existed throughout the program, which will be only present inside a function in which it is created. Okay, then second cause is also completed. Like first cause is deallocating memory, and second cause is returning address of a local variable. And the third cause which comes is pointer going out of scope, right? That means, yes, let's see with an example, then we can understand it very well. See, we are having a function void and in PTR, so means value at PTR. Okay, star PTR means value at PTR. This no problem, I cannot write it now. Let me type it actually. This refers to value at, and this %, refers to address of. Yes, you should remember both of these. Okay, then after that, yes, we have created a pointer variable and int x equals to 20, right? We inside this function, this is a global variable you have to keep in your mind. Oh no, yes, it is a local variable only because the function is created here, right? So inside this, again we are having x equals to 20, right? And PTR equals to %x. And because x is created inside this, right? X is created inside that. That's because actually these lines should be interchanged. these lines should be interchanged. Okay. uh, yes, this should be here and this should be here. Okay. Now see, this is a global variable, right? And when comes to this is a local variable. This x is a local variable. So outside, if we want to get the address of x, it goes out of scope. That's because it is the out of function, right? Out of function, we cannot access x. It is only created, declared and used inside the function. Outside function, if we want to access x, it will give an error like x is not at all, not declared, not defined, like that. Okay. Then ptr is now dangling. That's because we do not have a value of x. So that's the reason ptr will become a dangling pointer. Okay. And I hope you understood 3 causes of dangling pointer. How in what reasons the dangling pointer occurs. Okay. Then we know the causes, then we have to know the cure, right? So see how to avoid dangling pointers. How we needed to avoid, how to avoid them means, let's see. Then after free, let me check. Yes, after free ptr, set ptr to null. See, here we are having free ptr, right? Here after this we have to set that ptr to null. That then when we try to access that ptr, it returns a value of null, right? It do not gives an error actually, because ptr do not have any value, but it is assigned to null. Null means nothing, right? So we are stating that ptr do not have any value. So that is a great way to avoid dangling pointers. So one of them is that. And second one, never return addresses of local variables. See, here we have returned that, right? See, returning address of local variables. This point to be remembered, right? This should not be done like this. So we should not return the value of, should not return the address of local variable. Here we are returning the address of local variable, right? So this will give different answers in different scenarios. If we run once, it will give some answer. If we run again, it will give another answer. That's because this x will be created and destroyed also. Okay. So it will be allocated in different memory locations. That's the reason never return addresses of local variables. Next, be careful with scope and memory management. Scope. What is the meaning of scope? See, that just states this second statement, which means, see, scope. We have to know the scope of this before returning something, right? See, if this is a global variable, then returning the address of it doesn't matter. But it is a local variable, then it will be a dangling pointer. So you have to be careful with scope and memory management. Memory management is nothing but this malloc free, right? See, allocating, and when it is deallocated, we have to be some cautious, like we should not access it, right? It is deallocated, so we should not use that pointer. So that's the reason we have to be careful with scope and memory management. Okay. And here we are having some example. Let's run this example in code editor. Yes, let me paste it. Yes, I have pasted it, but I should edit sometime. Yes, now we are having this line. This is normal for every C program. and this should be included because we are using malloc. This is a standard library function which consists which is included in hash include stdlib.h, standard library.h. okay, and void main from where the execution starts. And now we are declaring a pointer variable and allocating some memory. Okay, and then if pointer is not equals to null, means if pointer is allocated successfully, then value at pointer should be 42. okay, and here now I'm printing something, right? I'm trying to print something. I wanna print the value at ptr, which should return me 42, and I'm trying to print value of ptr, means I'm trying to print the address of 42. And next I'm freeing the pointer, right? After freeing the pointer, see, now dangling pointer occurs, right? So that's the reason I'm setting this pointer to null. We have seen that, right? See, after free ptr, set ptr to null. That's the reason we are seeing this, we are writing this line. Okay, let's run and see whether it is giving our output or not. Okay, yes, we are getting value at ptr is 42 and value of ptr is this. This address will be changed whenever we run this. See, now 552 we got, right? Now let me run again. See, 952 we got, right? 3000 something, 3059 something. That address will be changed. Now let me try something. Let me print ptr now. %u, which is access specifier of ptr's ptr. Let me print now. Let me see what does it give. 0. That's because it is assigned to null, right? That's why we are getting 0. These all the errors we have. We are going to okay, now we are getting 0 as this is assigned to null, right? So that's the reason. Let's see what happens when we comment this down. Let me run. Yes, because it is not freed up, right? See, it is not assigned to null. That's why it is giving some same value, right? Yes, so we have to assign to null when it is freed up. That's a dangling pointer. Yes, now we are getting 0. So that's the completion of the execution, and what we have learnt in today's class is dangling pointer. There are 3 common cases of dangling pointer, which is deallocating memory, returning address of a local variable, and pointer going out of scope. These are the 3 main reasons of dangling pointers. Then how to avoid them? See, after free ptr, set ptr equals to null and never return addresses of local variables. Be careful with scope and memory management, and this is a code you have to work on. Okay, so that's all for today's session. If you are having any doubts, comment me down in comment section, and if you have any queries, email to the mail id which is given in the description. And if you like this session and feel this session is useful, then like this video and share with your friends, and consider subscribing because it motivates me to do more videos. Okay, thank you. That's all for today.